I want to talk briefly about stretching and compressing graphs. So let's start out with a fairly easy function, square root of x. All right, if I wanted to stretch this vertically, what I would do is multiply it by some number. If I take this and I multiply it by 2, 3, or 4, or whatever, it's going to stretch it out vertically. If I multiply it by a number that's between between 0 and 1, say 0.1, that squishes it down. So if I put 0.5 in here, that's half the height of the original graph. There. So if I take this and I put in a constant, if I take this and I go from, say, 0 to 10, this is going to stretch the graph vertically when it's when c is bigger than 1, and it's going to compress it vertically when c is less than 1. Of course, if c winds up going negative, it's going to reflect it. Now, if I take this c and instead of putting it on the outside, if I put it on the inside, that's going to stretch or compress it horizontally. Now, the thing is, on a function like this, stretching and compressing vertically or horizontally, they don't look very different. I mean, if I put the c there, or if I put the c outside, it's going to change which function we get, but it's not really going to look very different. It's actually easier to sort of get the gist of stretching and compressing if we use a more complicated function. So let's look at y equals sine x. If I wanted to, so the two things we're going to do is look at either putting a multiplier on the x itself, or putting it on the outside of the function. Let me type that again, like this. I'm using a and b here because those are typically the things that are used for a sine. So my a, when a gets big, that stretches the function out. So I'm going to put the original sign down here. So when the a on the outside gets big, it stretches it. If it gets between 0 and 1, it shrinks it down. And if it goes negative, it flips it upside down, and then it either stretches it if you're bigger than -1, or if you're down here between 0 and -1, it compresses it. Okay, now b, it's kind of interesting what b does. With b, on the inside, when b gets big, that compresses the function. When b is small, it stretches it out. And of course, when b goes negative, it reflects it across the y-axis. So we can do this to stretch and compress a graph.